Oh, that's your dad?
Okay, I thought it was someone else.
I was like, whoa, Helen.
Oh, with a heart next to it? No. Alright.
Are you done, Mama?
Productive.
Yes, we have to be productive because you have tests the next 2 days so that you can have a free day on Friday. Okay, so do we need to do anything off the front besides number 4?
One.
Oh, Helen, I have one.
No, this week it's Wednesday, Thursday, because Friday we're making hand turkeys. Okay, so tomorrow you have your partner test. Tomorrow's Wednesday. Over just the review. And then Thursday you take your CBA, which is the review plus related rates and implicit, which are on your CBA review. Okay, did you guys get the key yesterday?
No.
Oh, yeah, I got it.
I sent it
Okay,
on
maybe
Remind
my
101.
notification.
Okay, it's on my Weebly website, so
Remind sucks.
okay, you can also get on to
I just got it.
missjoyner.weebly.com, and if you go to the video lessons tab, okay, there's only like 3 tabs: Algebra 2, AP Calculus, and then video lessons. The top one is the answer keys for your review. I also linked the video for the study sheet there. Okay, so obviously I don't, expect you to save it as a favorite. Okay, but like pretty much, if I put something up, I also put it there. Okay, that being said, we're doing number 4. Okay, so look at it. Says, Mighty Cable Company manufactures a cable that sells for $120 per meter. The cost of producing a cable depends on its distance from the beginning of the cable. The cost to produce a portion of cable that is X meters from the beginning of the cable is $6X per meter. Find the maximum profit that Mighty could earn on the sale of one cable. Justify your answer. Then it gives you a reminder that profit is the difference between the money received by the company and the cost of producing it. Okay, so first thing I want you to look for is your goal. Now, obviously I picked this one because it's wordy and it's hard. The math is super easy though, but it's the setup that's harder, and this is where sometimes AP will get you. So first thing I want you to do is identify what's our goal. Max profit. Okay, so goal is max profit. Okay, so my P of X needs to be my profit equation. Okay, now remember, profit is 2 things. It's how much money you earn minus how much it costs you to make it. So first let's talk about the earn. This part is easier. Okay, look at the first sentence. It says, how much does it sell for? 120 per meter. So what would I need to do if I want to find how much money they made off the cable? 120x. Okay, that's how much it sells for. Now, the cost here is written in a more tricky way. Okay, what it says is the cost of producing it depends on the distance from the cable. So, is it always the same amount for them to make the cable? No. Okay, look at this though right here. It says the cost is $6X per meter. So notice there's already a 6 in the 6X, but then it's still per meter. What do we need to put with 6X? 6X squared. Okay, one more time, think about why. It's 6X per meter. That means that I need to multiply by another X, so that makes it 6X per meter is times X again. Just like it was 120 per meter we times by X, this 6X is going to be multiplied by X again. From here, it's super easy. What are you going to do with your P of X equation?
Combine like that.
Okay, combine. So if that's an X times X, what is that really?
6X.
Okay, 120X minus 6X squared. If that's your P, what are you going to do next?
P prime.
Okay, find P prime. Then what are you going to do after that? Set it equal to 0. Okay, then when you find your critical numbers, you're going to check and make sure it's a max. Okay, it should be the only one, and then you can keep going through. So what is my derivative?
120 minus 12x.
120 minus 12x. Then I can take out a 12. That gives me 10 minus x,
10.
which means what's my critical number?
10.
X is 10. Okay, then you would do your line test. Notice I can start at 0 because you can't have a cable with a negative length. That wouldn't make sense. Okay, so 10 goes on here. Pick a number smaller than 10. Maybe you pick 2. What is 10 minus 2?
Positive.
Positive. 11. 10 minus 11 is
Negative.
negative. If this is P prime, that's telling me what the profit is doing. Because that's what my P of X is profit. Profit was increasing until 10, then it was decreasing after 10. So where does my max happen?
10.
At 10. Now go back and read the question.
Yeah.
X represents the length in meters, right? That's how long your cable is. So I want 10 meters long. Is that the answer to the question?
No.
Okay, it says find the max profit. So the max profit occurs at 10, but 10's not the answer. What do I have to do with 10?
Plug it in.
Go back and plug it in. So my max profit occurs at 10. I'm going to write it like this. Max profit is blank at x equals 10. And then I'm going to take 10 and I'm going to plug it back in right here to my original equation. You could plug into this one or this one. It doesn't matter as long as you hadn't taken the derivative yet. So profit at 10 would be 120 times 10 minus 6 times 10 squared. Could you leave it like that if you wanted to?
Mm-hmm.
Sure. Okay, but if you don't, timesing by 10 just makes this 1200. That's 100 times 6 is 600. And 1,200 minus 600 is 600. Okay, so your technical answer here would be the 600. Even though it occurs at 10, you want to make sure that you're answering the profit aspect of that question. Okay? All right, turn the page. Any questions along the way? 14? Really? No.
No, because I stop it. Concave down means you have to take another derivative.
Yeah,
You have to do
you'd have to
double.
do the second derivative. Okay, this one is almost exactly like a gazillion homeworks. This one is as well. Okay, turn the page. We're going to do this one together, right here.
This one, oh, okay, can we do 5, like the calculator practice part?
Yes, we are going to do those. And you guys all got a calculator, right?
Yes.
Okay, if you didn't, I want you to read through it, okay? And I'm going to do the first part, and I want you to do the second part, okay? And if you don't have a calculator, I'll bring you one. Okay, so it says, a squirrel starts at building A at time 0. He travels along a straight horizontal wire connected to building B. Okay, for 0 to 18, the squirrel's velocity is modeled by the piecewise linear function defined by the graph above. Okay, all that you needed to get out of that is he's traveling on what kind of wire? Okay, that means he's going left and right. Okay, and the other thing that you should have gotten is that what is this a graph of? His velocity. Okay, this is his velocity. Okay, so let's say that I'm doing the first question. It says, find the squirrel's velocity, acceleration, and speed at time 8. So put a dot on 8 on your graph. Remember, this is a graph of velocity. What is his velocity at 8? 10. What is his speed at 8?
10.
10. The same, right? What's the difference between velocity and speed? Speed is always
Just the number.
always positive. Okay, so if your velocity came out negative, okay, you would change it. But if it's already positive, you're good. Okay, your velocity and your speed are the same. Now, what will acceleration be if this is a graph of velocity?
Slope.
Okay, very good. Acceleration is going to be the slope of velocity. Okay? So, look at 8. I need you to count the slope of that line segment. Okay? Now, I would always recommend that this case, it does turn out to be a really easy slope, but I would always use your endpoints. Okay, because sometimes that might not be right in the middle, and if you just kind of like, oh, it's about 10, then you could get messed up. So if I go down 20 and over 2, what does my slope come out to be?
20 over 2.
Negative 10. Very good. Notice the negative because it's downhill. Okay? So I'd like for you to do the second part and part B. Okay? And honestly, you can probably do part C too. Okay? And if you need a calculator, I'll bring them around. Just like, get my attention.
Just like, I did it earlier.
Also, do one of you accidentally have a calculator at
And
home?
then I will put it remember it? Concave down, concave up.
You? Do you have one?
This one? Positive, negative,
course.
positive. Yeah, because I forgot to
Need one? Do you need one?
So that's why
No?
So that's why I got 2
No?
0 upward.
Oh, shoot. You need this? P.S. Justin, I'm officially gonna have you detail my car. Because you know I had that camping trip this weekend.
Yeah.
My friend's daughter barfed all over my car.
Oh my god.
All over it. So he scrubbed the seats really good with this like thing, but I just
Yeah, no, totally.
I'm disgusted. So. And he like wiped it with wipies so that now there's like, you know when you wipe something with like paper stuff and it like leaves white behind? So it like looks worse. There's no barf on it, which is a positive. But yeah, it's great. All right. Okay, what is the velocity at 10? Negative 10, but what's the speed? Still positive. Very good. What is the acceleration at 10?
Undefined.
Undefined white. Yes.
Okay, this
Okay, so it does not exist. Okay, there is a distinction, and I actually didn't know this, but you can't, I always thought you could just call it a cusp or a corner and it didn't really matter. Okay, but remember how we talked about a cusp is curved and a corner is straight? Okay, if you called that a cusp, you wouldn't get points on the AP test. So this is considered a corner because they're both lines. If one of them was curved, you'd be fine calling it a cusp. Okay, so because
when is it carved?
there is a
Cuz.
corner. Okay, so remember, you cannot have a slope if your slopes from both sides aren't the same. So if I'm looking at this one, on this side my slope is negative 10, but on this side my slope is 0. That means you do not have a slope at that corner. Okay, part B. At what time does the squirrel change directions? Where does he change directions?
9 and 15. 10.
Very good. Okay, he changes direction at t equals 9. He changes direction at t equals 15.
I didn't know. Right.
Okay, what would your justification be? How do we know he changes direction?
Change the sign.
What's it?
The velocity.
Okay, good, because v of t changes sign. Okay, next question. Hopefully you got this one. It says, at what time, if any, does it should say squirrel, have a relative maximum in his distance from the building? Which of those is a relative maximum?
At 9.
At 9.
Velocity.
Okay, this one is a max. What is 15? A min. Okay, so basically what happened is this whole time that our velocity is above, our squirrel was going forward. Okay, then maybe he's like, oh no, I left my nut. Okay, so then he goes back and gets it, and then he starts going forward again. Okay, so he's going to the right. Okay, then he's going to the left. Then he's going to the right. So it should make sense that this is a max, because he was going forward, and then he turned around and went backwards. Okay, so you have a max at t equals 9 because v of t changes positive to negative. Okay? The last one says, part D, find average acceleration. Okay, this is velocity. What is acceleration? It's the slope. Okay, now this is important. So acceleration is the slope of velocity. Remember that there are two kinds of slope. You have an average slope and you have an instantaneous slope. Do y'all remember these two?
Yeah.
A rock and I rock. Okay, A rock is this one. Okay, and this one would be F prime at A. So remember the difference. Okay, if it's an average rate of change, you're doing normal slope. But if it's an instantaneous rate of change, that's the derivative. Okay, so what are we doing here if we want the average acceleration?
A rock.
A rock over 0 to 4. So I would do V of 4 minus V of 0 over 4 minus 0. Okay, V of 4, look at your graph. What is V at 4?
20 minus 0.
Okay, and look at my chart up here. Okay, V of 4 would be the height of the graph at 4, which is 20. So that's right.
No.
Okay, 20 minus, what's V of 0?
0.
0 over 4 minus 0 is 4. What's 20 divided by 4? 5. Okay, now let's talk about units. On the top, we are subtracting velocity, which is in meters per second.
And then seconds.
On bottom, it's seconds.
So meter per second squared.
So it'd be meters per second squared. Okay, so remember that if you take the slope of velocity, you should be getting acceleration. Okay? All right, second part of the question.
Second part.
Yes. Okay, it says, does mean value theorem guarantee that there has to be a time on 0 to 4 where acceleration is equal to this value?
No, because it's a corner.
That's exactly right. Okay, so this is what mean value theorem says in case you forgot. You have a cheat sheet hopefully still somewhere with it written on there. Mean value theorem says that on 0 to 4, this is my average rate of change. Okay, if that's my, you can't see it. If that's my average rate of change, mean value theorem says there has to be a point that has exactly that same slope. Okay, does that happen though? No, you can see this slope is 10, this slope is 0, but this slope came out to be 5. Okay, why does mean value theorem not apply? Because of this. Okay, mean value theorem only applies if your function's differentiable. Is it differentiable if there's a corner? No. So your answer for that would be MVT does not apply because V has a corner at, where is it? T equals what?
2.
2. And because 2 is on your interval from 0 to 4, that matters. If it had a corner somewhere else, not between your points, you wouldn't care. But because that's right smack dab in the middle of your interval, that matters. Okay? Alright. The next one that we're going to do is the very next free response that's kind of long. Okay, so what I would like for you to do... Oh, wait, hold on. Not that one. Where's the one with the 2 particles? Right here. Number 6. This guy.
Oh, yes.
Okay? So, this is an AP question. Half of it is really easy, half of it's really hard. Look at your equations. Now, when I say really hard, okay, keep in mind, we're going to do it together. Okay, look at your 2 little guys here. Which one do you think is going to be really easy?
Second one.
This one, right? It's a normal polynomial. Which one's probably going to be harder? The one with the trig in it, okay? But we can do it. So we are going to work A through D, but only with R first. Okay, so I'm going to help get you started, but notice it says for P and R the whole time. We're going to just only do R. Okay, so this is R. Okay, notice it says we're going along the x-axis and we're only going from 0 to 6. Part A says to find the velocity. How do you find velocity if you know the position?
Derivative.
Okay, so we're going to put r prime of t equals, find it.
3.
Okay, then when you want it to be at rest, what are you going to do next? Because I'm about to give you a cookie for trying.
Equals velocity for
Okay, you're going to take the derivative, set it equal to 0. Then down here, when you want to know when your particle's moving to the right, you're going to do a first derivative test. Okay? So work through all of that part for me. Okay, and I'll come bring you a little treat. Okay? It's an Oreo. Don't get too excited. So you're taking the derivative, setting it equal to 0, finding your critical numbers, blah, blah, blah.
Yeah. See? This one's harder. P is harder.
My cookie. What happened, Grady?
Just work and stuff got a lot less. Lots of things.
Did it like actually get crushed, or it just is really sore?
It was never crushed, but my knuckles just got worse from work. A lot worse.
Helen's done.
Okay, how'd it go? Easy or hard? Okay, hopefully pretty easy. 3t squared, 12t plus 9. Take out a 3. How did it factor? Minus 1 and minus 3, right? Okay, so your critical numbers are 1 and 3. What if it said to justify at rest? What would you put?
Because,
V of t is what?
not.
0, right? At rest means not moving. That means its velocity has to be 0. Okay, then for your sign chart, if you put arrows on the end, technically that's not really in sync with what the question said, right? Said from where to where? 0 to 6. Okay, so that's okay. You probably wouldn't have lost a point, but you might have. So 1 and 3 are my critical numbers. How did my signs go? Let's go left to right.
Positive minus positive.
Plus, minus, plus, which means if I want my guy moving to the right, which intervals do I want?
0 to 1 to
3 to 6. Okay, let's pretend like it said justify because V of t greater than 0. If it said to the left, you'd want your negative intervals, which would be when your V of t is less than 0. How should I label my sign chart here?
0 to 6.
Down here it would be velocity. Up here it would be r. Okay? You could also label this r prime if you want. That would be fine. Technically, probably down here I would put r prime of t instead because it's more consistent with your problem, but if you put v, you'd probably be fine. Okay, let's scooch over to our little trig guy. So we want the velocity, we have the position. Okay, so velocity is going to be the derivative, p prime of t. Think about your snow cone, snow cone, snow cone, snow cone. Okay, if I'm at cosine, I'm going down that list. What's the derivative?
Negative sign.
Okay, so negative 2 sine of pi fourths.
The chain rule with the pi.
Okay, very good. Your chain rule says that you have to multiply by the derivative of the stuff in the middle. So if it was a 3x, right, your derivative would just be the 3. Well, then if it's a pi fourths t, what's your derivative? Just pi fourths. Okay? So next we want to know when the particle is at rest. What are we setting this equal to? 0. So 0 equals negative 2 pi over 4 sine pi fourths t. Now, could you reduce that? Sure. Okay, but do you have to? No. Okay, from here, pi fourths is which finger? Middle. Okay, what is the sign of, oh wait, hold on. Backtrack. We're setting this equal to 0. We're not plugging that in. When is sine 0?
When?
On your hand. You want no fingers on the bottom. 0. So t would have to be 0.
I was right.
Okay, now there's one other point that this happens, and you would have gotten partial credit if you found 0. Okay, I want you to think about on your unit circle. Okay, here's 0, here's pi, right? Okay, so whenever I'm at 0 or pi, sine is 0. Okay, I want you to think about, don't say it out loud, think about what t would have to be so that it would cancel out this 4 and leave me with just a pi. Just think about it. Okay, what number would t have to be so that it would cancel out this 4 on the bottom and just give you a pi? Because that's your other 0. What would it have to be? 4, because 4 over 4 cross out and then you just get the pi. Yeah? So 4 would be your second critical number. That one would be a lot harder to find. Okay, but hopefully it makes sense why. Now, if that was really hard for you, this is what I would say. If you take the middle chunk and you set it equal to what you want, which was, we wanted it to be pi. Okay, well then think about how would I solve that? Times by 4 over pi, and then what happens? You still get 4. So if you want to do it algebraically, you take the middle chunk, set it equal to what you want. Okay, if you're a little bit lost, I would say if you got this side, this is what's on your test tomorrow. There's a very low chance they'll give you one this hard, but I don't want to not teach it to you, and then if they do it, you've never seen it. Okay, so 0 and pi fourths are our critical numbers. Set up your number line. 0 actually doesn't really even need to go on there. 4 is over here. 6 is the end.
What if we only write 1?
You would get 1 point. You would have missed a point, though. Okay, from here, we are going to plug in, let's say, 1. Okay, 1's going to be our test point. So we're plugging in to right here. Okay, I'd have negative 2 pi fourths times the sine of pi fourths times 1. Now, is 1 going to change that pi fourths? No. What is the sine of pi fourths? We're still here. Square root of 2 over 2. But then I'm timesing it by a bunch of negative stuff. So it's going to be negative on that interval. Okay, what could I pick between 4 and 6? Okay, let's plug in 5. So I'd have negative 2 pi over 4 times the sine of, now look what happens. When I take this 5, I'm plugging it in right there. Now it's a 5 pi over 4. So think about it. I'd still pick the root 2 over 2, but if this is 4 out of 4, where would 5 be? Down here, right? Because if this is 4, I'd have to go to 5. That puts me down here. All students take calculus. Tangent is positive. What is sine?
Positive. I mean negative.
And if sine is negative and I'm multiplying by a negative, what's the overall sign? Positive. Okay, if that part was hard, I would say just from here, you should be able to get back on track with us. Okay, so this is negative, positive. When is the particle moving to the right then?
4 to 6 because p prime is...
Good, so this would be p prime, this would be p. So he's moving to the right on 4 to 6. Okay, if it said justify, you'd say because p prime is positive. Okay, so down, up. Okay, next question. So we have our two sign charts. It says, find the times when the particles are traveling in opposite directions. Is that a double or a single sign chart if we want them going opposite ways?
It's just...
Double. And what am I going to put? I'm going to put both of their velocities next to each other. And what do I want their signs to be? The same or different? Different. So let's set them up right on top of each other. Keep in mind, we've already done most of the work for this. This is going to be r prime, this is going to be p prime. Okay, and the order there doesn't matter. Okay, for r, that was my easy one. My critical numbers were 1 and 3. So 1, 3. My signs went plus, minus, plus. Okay, for p prime, my only critical number was really 4. And what were my signs? Negative, then positive. So I'm going to put negatives all the way across here. Okay, and then a positive. Because it was negative that whole time. Okay, when are they going opposite directions? When the signs are opposite. So what interval?
0 to 1.
Okay, 0 to 1. Which way is particle r moving here? Right, but p is moving left. That's opposites. Okay, what about in here? They're both moving left. Do I want that? Okay, where else?
3 to 4.
3 to 4. Okay, and your justification would be because r prime and p prime have opposite signs. But notice it doesn't even tell you to do it, so you don't have to justify. Alright, next two questions are only about R, which is good news because that's not our trig. Okay, it says, when is the velocity increasing? The next question says, when is the speed increasing? You have several questions exactly like this on your test. So let's remember the difference. Which of those needs a double line chart? Velocity or speed?
Speed.
Velocity.
Speed.
So the answer would be you need a double when it's speed. Because remember, if velocity and acceleration are the same sign, that tells you you're speeding up. Velocity, think about. If I want velocity increasing,
Yeah, but for velocity, you have to take a prime.
okay, listen, velocity increasing means velocity's slope is positive. What's velocity's slope called?
Or acceleration.
Acceleration. Okay, so if velocity is increasing, your acceleration has to be positive. Now, what about for speed increasing? Good. V of t and A of t need to have the same sign. Do they both have to be plus?
No.
They can also both be minus. Very good. So make a little note of that. That's already on your cheat sheet or your study sheet. So if you've already made that, you should have that written down. Okay, so we need to check a sign chart on acceleration. I'm going to write my r prime back down here. Okay, it was 3t squared minus 12t plus 9. What is r double prime then for acceleration? Okay, set it equal to 0. What can I take out? T minus 2. What's my critical number? 2. Put it on your number line. 0 to 6. 2 is my only number I'm checking. Plug in 0. What's 0 minus 2? Negative. Plug in 3. 3 minus 2 is positive. Then let's label this acceleration and velocity. When acceleration is negative, what is velocity doing? Decreasing. When acceleration is positive, what is velocity doing? Increasing. So when is my velocity increasing on which interval? 2 to 6. Okay, next I want speed, so I'm going to take my velocity one from up here and I'm just going to write it right underneath. Okay, so this is velocity, now I'm going to do my double right underneath. What were my critical numbers? 1 and 3. And what were my signs? Plus, minus, plus. Good. Now I want the same sign. And make sure you want to line it up. So like your 1, then your 2, then your 3. So it's lined up. Okay, where do I have the same sign? What's the first interval? 1 to 2 and 3 to, should I put infinity? 3 to infinity? 3 to 6. Good. 1 to 2, union 3 to 6. Okay, because, and then I'm just going to put an arrow for that. V of t and A of t have the same sign. Now technically this would really be r prime and r double prime, but you get the idea. Okay, last one on this question says, find the acceleration of the particle at 3. Okay, what is acceleration? That's the second derivative, or the slope again. Okay, but for which particle? P. So let's remind ourselves what P prime was. P prime was negative 2 pi over 4 sine pi fourth t. So if we want acceleration, this is velocity, we need to take the derivative one more time. Think about your snow cone, snow cone. What's the derivative of sine? Good. So P double prime is going to be negative 2 pi fourths cosine pi fourths t. But then I still have to do my chain rule again, so what am I going to multiply here in the front? Another pi fourths. Now, do you have to simplify that? No. But But the second one comes into play because that's the derivative of the middle. That's your chain rule. Okay, now where do we want the acceleration at what time? 3. So p double prime at 3 is going to be negative 2 pi squared over 16. Okay, and you could leave that separate if you wanted to. Okay, but the real thing we need to focus on is this. This is now the cosine of 3 pi fourths. Do we understand why that's changing to a 3 pi over 4? Okay, because I'm taking the 3 from right here and I'm plugging it in right here. Okay, now think about what quadrant. So pi fourths is still in the middle. It's still root 2 over 2. But what quadrant am I in if I'm at 3 pi fourths? This is 4 pi fourths. So I'd be all the way to here, and then I'd stop. Is cosine in that quadrant? All students take calculus. Cosine is positive or negative? Negative. So this would be negative 2 pi squared over 16 times negative root 2 over 2. And why does that matter? What's going to happen with those two negatives? It's going to cancel out and be positive. So then my question says, am I speeding up or slowing down? If acceleration is positive, is that the end of my analysis? What else do I need to know for speed? Not just acceleration, but velocity. Come back up here, be lazy. Okay, look. At 3 would be right here. What is my velocity? Was it positive or negative? Negative. And so if my velocity is negative, but my acceleration came out positive, what would your answer be? It'd be slowing down. Good. Okay. If your acceleration was 0, then that would mean your speed's not increasing or decreasing, it's staying constant. That's a good question. Okay? Alright, the last thing that we're going to do is we're going to work the calculator practice page because I want to make sure you remember how to take derivatives using your calculator. Okay? So, last page. Go ahead and type in that very first equation.
Wait, is it, which one is it?
Oh wait, hold on. Oh, I think I stapled mine stupidly. Okay? Or maybe I had you do the same. Go to the one that says calculator practice. And it looks like this. Okay, then when you get it, go into y equals, and I want you to type that equation in. Right there.
Okay.
So y equals 6.342 e to the 0.011x. Alright, while you're typing, I'm going to read it to you. It says, according to the census, the world population is approximately that billion people, where T is measured in years since 2004. Okay, part A, what was the population in 2004? Well, if this is what I'm counting from, what time would that be? 0. So, look in your table. What's the value at 0? How many people? Okay, 6.342, but what would that be measured in? Billions. So you would put P of 0 is 6.342 billion people. Okay, next we want P prime at 4. P prime at 4 is the derivative. So I'm going to show you two ways to do it. The first way is going to be in graphing, so go into it. Okay, my graph is kind of zoomed in, but as long as 4 is on it, see how I want it at 4? That's fine. I'll make it just look normal so that you don't think it's weird. Okay, so here's my normal graph. I want to take the derivative. Second trace, and then which one do I want? dy dx number 6. Then you have to tell it what the x is. Where do I want the derivative at? 4. So I'd type in 4 and then enter. Okay, what did it come out to be?
0.079.
Good. So P prime at 4 is 0.0729. Now, what would that be measured in? This is measured in people, T is measured in years. So what would the derivative be?
That many years
Billion people
per year.
per year. Now, question. Your rate came out positive. Does that mean that the population is increasing or decreasing? If it came out positive,
It's a derivative.
increasing. Okay, so for the interpret its meaning, you would say at T equals 4. Now, quick question. If we're counting since 2004, what year are we in if we're 4 years later? 2008. Population is increasing at a rate of 0.0729 billion people per year. Okay? At T equals 4, which would be the year 2008, population is increasing at a rate of 0.0729 billion people per year. Number 6 is almost the same, so I'm not going to do it. But number 6, I think your rate comes out negative. So instead of saying increasing, what would you say? Decreasing. Okay. Let's go down to number 4. Okay, number 4 says you have a particle going on a straight line. The velocity is given by a really complicated equation that I did not teach you how to take the derivative of by hand. So you got to know how to do it in your calculator. Says if this is velocity, what is the acceleration at time 3? What do I need to take? The derivative where? At 3. So go into y equals, type that new equation in. Okay, so 7 minus 1.01 to the power of negative x squared. And I'm going to show you how to do it not in the graph. So once you type it in, I want you to hit second quit and just get in your normal screen. Okay, second quit. Okay, remember that to take the derivative, you're going to push math 8. And it's going to bring up d blank, blank, blank. Okay, it's d dx of y1 at whatever you want x to equal. Okay, so watch me do it on here. Okay, you can see what I wrote down here. Okay, but I'll show you in the calculator. So I would push math 8. Then I want d dx of alpha trace y1 at 3. And you can do it that way too. Could you also do it in the graph? Absolutely. Okay. So 0.0545, which rounds to which answer?
B.
B. So 0.0545, which is the same as B. Okay, great. We're right on time for one more. Okay, last one. Now, your calculator, this is what your calculator can do. It can take a derivative at an x value. It cannot take the derivative at any x value. So up here, if I want the derivative at 3, your calculator's got that. Okay, but look at the next one. If you have a function, your calculator cannot find f prime of x for you. Do you see the difference? It can take it at a number, but it can't take it as an equation. So that's where you got to know how to take derivatives. So if this is f, let's think about what f prime would be. My first question, okay, trick question here. Do I need product rule for this?
No.
No. Does sine have its own x?
No.
No, then it's chain rule. What is the outside function?
Cosine x squared.
What's the outside function for f? Sine, right? And the derivative of sine is cosine. So f prime of x equals cosine of x squared minus 6x. And remember, you keep that little middle chunk the same, then I times by the derivative of it.
2x minus 6.
Good. So I'm going to multiply then by 2x minus 6, where that's the derivative of this. Y'all remember chain rule? So you keep the middle exactly the same, and then you multiply by its derivative. Okay, I want you to graph this in your calculator on 0 to 2. Okay, if you graph it 10 to 10, it looks crazy. So make sure you adjust your window 0 to 2 first.
So cosine
and then it says sketch the graph below, so I'm going to sketch it right here. So it's down, up, down, and then it barely crosses at the end. Okay, the first question says, part A, find the critical numbers, label as a min, max, or neither. What points would I be looking at on my calculator for a min, max, or neither? The x-intercepts, very good. This one, and this one. Okay, let's review how to find those. Hopefully you remember already. Okay, if I'm finding this one, I'd hit second trace. I'm finding the 0, which is option 2. And then remember, this is 1. So I know it crosses between 0 and, let's say, a half. So for my left bound, I'm going to put 0. My right bound, I'm going to put 0.5. Then check your arrows. Okay, does it cross between those numbers? Look at my little arrows. Yeah. So then you push enter. Or you can tick, 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 move the little thingy all over the place. Okay, 0.2743. Got it? Okay, find the other one. Okay, second trace, we're finding the second 0. My left bound, I'm going to make 0.5. My right bound, I'm going to make 1.2. Okay, I see my arrows. Do sandwich it in the middle. Okay, 0.9293. And then I think the other one is 1.9293. So you can just skip that one for now because we're low on time. Okay, which of those is a max? First, second, or third. Look at the sign change.
Positive, negative, the second one.
This is the max. Good. Okay, what are the other two both? Mins. Max, min, min. Okay? If you had to justify, you would say because, we'll just do it for the last one, V changes negative to positive. Okay, the last part asks you for points of inflection. Where are those on the graph? We usually put X's on those spots. Change in slope here and here. Those are your points of inflection. How would I find those on the calculator under second trace? Max and min. And you'd have to pick what kind it is. So if I want this one, I'd be looking for the max, which is option 4. And then I can see it happens between, let's say, 0.5 and 1. Oh, and I missed it. So I have to make my max and min maxier and minier. We'll go 0 to 1. Okay? Your max should happen at 0.5623. And then if you find the other one, 5623, I'll put a comma, you would find it. Okay? If you have my calculator, give it back. And have a great day. I have to cover the freaking class. So, no. Unless you want to come with me to whoever Miss Armette is. She's all the way in A Hall on the first floor.
Yeah, it's fine. But I have to go.
Yeah. And then 7th period tomorrow too. Yeah? And if you want to come 7th today, I actually can do today. If it's like a couple of quick questions.
No, I got one today. So
Okay.
I'll come by in a few minutes.
Okay. But it may take me a minute to get up here since I'm all the way over there. Yeah, what's up?
I was sick Friday, and so I couldn't be anywhere. Sitting on
Oh.
I'm here.
We haven't. I don't even know what happened last week because I was at that calculus thing. So I don't know if that's still the wrong test. But Justine's out all week. But you're right, we haven't done any eyes. Did you pull it off the Google thing?
Oh, it is worse.
Yeah.
but not the operation, that's complex numbers and that's after.
Yeah, I mean, I haven't even talked about the square root of -1. I'm gonna just talk about it, I don't have,
It was very brief and,
Yeah.
you know.
because we're not there yet, so I wasn't gonna
Okay.
drive myself crazy to try to halfway, I would rather just teach it when we teach it, you know what I mean?
Absolutely, because it's not, and I don't even know how do you graph one? I don't know, we didn't graph them. It was like.
You
okay,
would have like, this is the I, you would have to make that the I axis, so then it would be 2I and 4I you'd go to on those axes.
But I don't want to touch.
But I don't even know why they did that. I
Okay,
have
just
no
check.
idea.
All right, so I'm gonna take that off,
Okay,
and it's a shame because we have all of our copies have been made, but
well,
I
I
can't
haven't,
give
I'm
that to
doing a
the-
different test, because I didn't, I mean, I'm gonna look at it and try to use most of it, but we took a bunch of stuff off of there that we should not have taken off. Oh crap, I'm still recording this.
like what?